Okay, so for class exercises number 1, they give you a coordinate and they're asking for sine and cosine. The first thing you have to do is find the radius. You're going to x squared plus y squared equals r squared to find the radius. Our x coordinate is -3 and our y coordinate is 1. Don't forget, when you square a negative, you get a positive. So this is 9 plus 1, which is 10. And then you're going to square root both sides. And so your radius is the square root of 10. You can't break square root of 10 down. So square root of 10 goes there. Now what we're going to do is we're going to take a look at the sine and the cosine. So the sine of theta, as we've learned, is y over r. Our y coordinate is 1, and our radius is square root of 10. So all you have to do is rationalize. And your answer will be the sine of theta is 1 radical 10 over 10. It's positive because sine is positive in quadrant 2. The second one we're doing is cosine. Cosine is x over r. Our x value is -3. Your radius is still square root of 10. You're going to rationalize. So cosine theta is -3 square root of 10 over 10. In quadrant 2, where this is located, cosine is negative, so that makes absolute sense. The next one we're going to do is number 3. For number 3, they give you a quadrant 3 angle at -10, -8. So again, the first thing we're going to have to do is find our radius. So we're going to use the formula for our circle, x squared plus y squared equals r squared. And we're going to plug in x and y, keeping in mind that when you square them, it's going to end up being positive. So that's 100 plus 64. We're going to square root that. And I can see right away that 4 goes into this. 4 goes into this 41 times. And since 41 is prime, 4 is the biggest. So the square root of 4 is 2. So our radius is going to be 2 radical 41. Now what we're going to do is we're going to put that over here. And then we can find sine and cosine. I'm going to do it over here though. So my sine is y over r. So my y is -8, and that's over 2 radical 41. The first thing we're going to do is cancel the 2 and the 8 and reduce it. And then we're going to rationalize. So on the top, I have a negative, a 4, and a radical 41. And on the bottom, I've just got 41. Sine is negative in quadrant 3. And that makes sense. Cosine's the other one. I'll do that one over here. Cosine theta is x over r, and x is -10. Again, same thing. I'm going to reduce the 2 and the 10, and then rationalize. So cosine theta is -5 radical 41 over 41. Cosine is also negative in quadrant 3. So this makes sense. The last piece that we're going to do is number 4. And number 4 simply says, is the expression going to be positive or negative? So positive and negative values come from our all students take calculus. And that means that all are positive in quadrant 1. This means sine is positive in quadrant 2. This means tangent is positive in quadrant 3. And cosine is positive in quadrant 4. All we have to remember when we're doing this is that around the unit circle, I've got 0 degrees. On the top is 90. On the side is 180. On the bottom is 270. So depending on where your angle falls within these categories is going to determine which it's positive or negative. Okay, so it looks like a lot of these, but it's really not. So the first one is 4A, and it says sine of 165. 165 falls between 90 and 180, and that's where sine is positive. That's it. B is sine of 265. 265 is between 180 and 270. Because it says tangent is positive, then sine automatically defaults to negative. Because tangent is the only one positive there. The third one is cosine 210. 210 falls between 180 and 270. And again, tangent is positive, so cosine 210 is negative. In the next one, we have cosine 310. Cosine 310 is between 270 and 360. 310 is here where cosine is positive. Then we're on radians. So I'm going to set these up and I'll be right with you. Okay, all I did was copy the problems down so that I could go through them a little faster. So if you need to pause and copy them down, that's fine. I also have my calculator handy. I think it's going to be kind of good. I don't know if we'll need it. So I'm really good at degrees, not too great at radians, but I'm good at degrees. So what I'm going to do is I'm going to use my conversion factor to convert. So I'm going to take 5 pi over 6, and I'm going to multiply it by 180 over pi. That's what's going to give me my degrees. So my pi's cancel, and 6 goes into 180 30 times, and 5 times 30 is 150. So I'm actually looking for the sine of 150. Well, 150 is between 90 and 180, and that's where sine is positive. Cosine is, well, the radians are the same. So 5 pi over 6 is 150. So cosine between 90 and 180, it says sine is positive, so this defaults to negative. Now we have to do 4 pi over 3. So we're going to take 4 pi over 3. We're going to multiply it by its conversion, which is 180 over pi. That's going to give me degrees. So the pi's cancel. 3 goes into 180 60 times, and 4 times 60 is 240. So now I'm looking for a 240 degree angle. Well, 240 falls between 180 and 270, which is where tangent is positive. And if tangent is positive, then sine is negative. And the last one is 5 pi over 3. So I'm going to take 5 pi over 3 and do a conversion with 180 over pi. And we're going to cancel these, and this is 60. And this is going to give me a 300 degree angle. 300 falls between 270 and 360, and that's where cosine is positive. Perfect. I'm going to go ahead and set up the last 4, and then we'll be done. Okay, the last 4 are in radians, and the way we know that these are in radians is because there's no degree symbol on them, and because they don't have pi's, they have a different kind of conversion. So what we would do is we would go back to our unit circle, and we would go back to our quadrantals and write them in again, except we're going to write them in radian form. So remember, this is 0 radians. Pi over 2 means 3 pi. I'm sorry, it means 3.14 divided by 2. Numerically, that's 1.57. And then pi is 3.14. And then this one is 3 times 3.14 divided by 2, which is 4.71. And 360 is 6.28. So you need to refresh yourself on your radians and getting them into numerical form. You're just replacing 3.14 with that value so that we can figure out what quadrant these are in. So 2 radians is between 1.57 and 3. This is where 2 radians is. So this is a quadrant 2 angle. Quadrant 2 angle. This is where I'm starting. Then 4 radians is between 3.14 and 4.71. So this is a quadrant 3 angle. Now that I know what quadrant they're in, this is going to be super fast, because what I remember is that all students take calculus, all positive, sine positive, tangent positive, cosine positive. And because quadrant 2 is here, the sine is positive, and that means the cosine is negative, default. Down here in quadrant 3, tangent is positive, which means both of these have to be negative. And that's that. You guys are ready for your homework. Contact us with questions.